Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video we're going to be talking about factoring a trinomial. So this is different from factoring a four-term problem, which is what we learned in the previous video, a four-term polynomial. However, it builds on that step. So the stuff we did in the last video, in the last two videos actually, will come into play when factoring a trinomial. So make sure that you have those first two videos down. So how to factor out a GCF and how to factor a four-term polynomial. You don't want to try to tackle trinomials until you have both those steps down. So just keep that in mind. Okay, so a trinomial, a quadratic trinomial, is going to be in this form. So it's going to be ax squared plus bx plus c. Okay, when you see it's in that form and it is a trinomial, it's 1, 2, 3 terms, this is the process that you do. Okay, now I teach using the AC method and I incorporate the X, we call it the X box in my class. I incorporate the X box in that. I know some teachers have mixed feelings about it. I cannot suggest using an X box enough. Okay, I think that it really helps students. I see that they understand it a lot more when I've used this, particularly students who struggle with their multiplication tables and maybe don't know them as well. This is a major help. So I can't suggest that enough. All right, so let's just dive right in. Factoring a trinomial. So looking at this example, your first step, pretty much anytime you're factoring, your first step is going to be, do I have a GCF that I can go ahead and pull out? Doing so will save yourself time and it'll make the problem easier if you go ahead and do it. So let's see. I've got 1x squared, 2x, and a negative 15. So there is no GCF that I can pull out other than a positive 1, which wouldn't do anything anyway. So there's no GCF here. I can go ahead and proceed with factoring using the AC method. So the way the AC method works is you label each part of your trinomial. So as you can see in this formula that I have here, what goes with what is the coefficient of x squared? That's our a value. So here it's an understood 1 in front of that x squared. And if you need to see that, by all means, let's write it in. So we remember that's a 1. Okay? My b value is my coefficient of just the x. So that would be my 2. That's my b value. My c value is just my constant at the end. All right, so we need to create an X box. So we draw a big X. And you can see what goes on top of the X, what goes in this top V, is A multiplied by C, A times C. All right, so let's go ahead and do that. A, which is 1. Now, we only want the number. I do not want to use the X squared. There's no letters. You should have no letters in this box. Only numbers, okay? So 1 times your C value, negative 15. So 1 times negative 15 is negative 15. Put that up top. Now in the bottom V, you just put your B value, okay? So my B value is positive 2. The sign is very important. Make sure if it's negative, you write negative. If it's positive, you write positive. Same thing up top. Signs are very important. Okay, now our goal in doing this X box is to figure out what would be two numbers that multiply and give me negative 15 and add together to give me 2. All right, so I'll say that again. We're looking for two numbers that multiply together to give me negative 15, but they add together to give me 2. Okay, so we've got to fill in these two blanks right here. Now, I think it's easiest to do the signs first. So let's think. If I'm multiplying and I'm getting a negative 15, but it's a negative, the only way I could multiply and get a negative would be if one of these numbers was negative and one was positive. Because think about it. If they both were positive, that would multiply and give me a positive, right? And if they both were negative, that would also multiply and give me a positive. So the only way I can multiply and get a negative would be to have a negative and a positive. Okay? So easy to knock the signs out first. Now let's talk about our numbers. Well, let's think of everything that goes into 15. Okay? And there's only a couple things. All right? We've got 1 and 15. And it kind of helps, I think, to note this on the side or on some scratch paper. And we've got 3 and 5. Now, if you did not know that, because some students they just don't have those multiplication tables down. Okay? So let's say you did not know the multiples of 15. Instead of doing a bunch of trial and error, use this trick on the calculator. This trick really comes in handy when you've got big numbers that you're factoring. Okay, you go to your y equals, I showed this in another video, but I'm going to show it again. You type in the number you want, 15, divided by x. Hit second graph. This pulls up your table. And we can see everything that multiplies to give me 15. I've got 1 and 15. I've got 3 and 5. And if you scroll down a little bit, you've got 5 and 3. Once it starts repeating itself, you're done. Okay, now we knew those and we've already listed them out, but it helps to know that trick when your numbers get a little big. Okay, so let's think. I've got 2 potential sets here. Which one of these would potentially add to give me 2? Well, I know there's no way I can do a -1 plus 15 or a -15 plus 1. No way I'm going to get 2 out of that. It's just not going to happen. Cross it out. Now, 3 and 5, I'm thinking, yeah, but which one is negative and which one is positive? That's the number one question that I get when students are learning this is, well, does the placement matter? If one is negative and one is positive, yes, it very much matters. So which one should it be? So I know I've got a -3 plus 5 or a -5 plus 3. Test both out. If you're not good with mental math, use your calculator. -3 plus 5. There's my +2. Just for fun, let's show the other way. -5 plus 3. That will give me -2, which is not what I want. So placement does matter. So we want our 3 to be negative and our 5 to be positive. Okay, so why did we do all that? It's going to make sense in just a second. These are my 2 new numbers. That's a 5. Okay? I'm going to turn this trinomial into a 4-term problem using those 2 numbers. So let's do that. I'm going to rewrite this trinomial, and I'm going to call it a 4-term polynomial now. So A stays the same. Okay, and if you like seeing the 1, write the 1 in front. Okay, my B value, this is the one that's going to change. I'm literally going to split my B value in 2 using those 2 new numbers. Now remember, your B value has a coefficient of x. So both of these will now have a coefficient of x. So let's do this. -3x plus 5x. And my C value stays the same, -15. Do you see what I did there? I took my B value and I split it in 2 using these 2 terms. And I made sure I put an x with them because my B value has a coefficient of x. Okay? We turned this trinomial into a 4-term problem. That was the point of doing this, so that we could get the right numbers with the right signs to really do that and have it be correct. Okay, so now you got to think back to the last video. How do we solve a 4-term polynomial? Well, hopefully you're saying right now, we factor by grouping. Yes, we do. We group together the first 2 terms and the second 2 terms. Make sure you include your sign with the second grouping. Very important. Now, if you're asking yourself, what is factor by grouping? I don't know what she's talking about. Please go back and watch the video on factoring a 4-term problem, okay? It will make a lot more sense. So we want to factor out our GCF of the first group. I see I've got 1 and 3, so the biggest number I could pull out would be 1. I've got x squared and just 1x, so the most I could pull out would be x. So let's figure out what would be left in the parentheses after I divide out this x. X squared divided by x would just be x. Negative 3 divided by 1 would be negative 3. X divided by x cancels. All right, let's factor out the GCF of my second equation. But first, well, I went through this in that last video. Whatever that sign is, bring it down. Doesn't matter if it's positive or negative, bring it down. Don't forget that. Okay, so for my GCF, I've got a 5x and a 15. So I know 5 goes into 5, and I know 5 goes into 15, so it'll be 5. I can't pull an x out because that one doesn't have one. So I can only take what both of them can give me. So let's divide out that positive 5. Positive 5 divided by positive 5 cancels, right, to 1. I just have an x left. Negative 15 divided by 5, that'd be negative 3. Okay, now if you remember with factor by grouping, our goal is to get twins here. Twins, identical twins, all right, and we did. So I know we've done the job right. So what we do is our final step, so we do x plus 5 and x minus 3. Now, this is as far as we can take this particular problem. And the reason why we can't take it any further is because there's no equal sign. This is just an expression. It's not an equation. In a couple videos down the line, I think 2 videos from now, we're going to learn how to take this further and how to actually solve this down to an answer. So keep that in mind, but for now, if you just have an expression, this is as far as it can go. All right, let's look at another example. So again, when factoring a trinomial, we ask ourselves, do we have a GCF? That is always your first question. Do I have a GCF that I could go ahead and pull out? So let's see, I've got 2, 14, and 24. Well, I know 2 goes into 2. Does 2 go into 14? Yeah. Does 2 go into 24? Yeah. So I can actually go ahead and factor out a 2. Can I factor an x out? This one's x squared, that one's x. This one has no x, so no. I cannot factor an x out. All right, just a 2. So let's factor that 2 out. Let's divide it out and see what we have left. All right, so 2 divided by 2, that would cancel, and so I would just have x squared. 14 divided by 2, that'd be positive 7, and then I'd have my x left. 24 divided by 2, that would be positive 12. Okay, so we factored out the 2. That 2 is going to hang out with this problem all the way to the end, and it will be part of the answer, okay? But I think it's easiest just to kind of like write it on the side. I don't want to forget about it. Just kind of write it on the side. Let's rewrite my equation because this is my new expression. Okay, 2 will be part of the answer. And what I do so that I don't forget about that 2, because a lot of students, they factor it out and they remember that, but they don't remember to bring it down. What I like to do is go ahead and circle it and just do like an arrow down. And the reason why I do that is so that this 2, I know it's going to be part of the answer, but a lot of students tend to forget about it and leave it up here. And then technically their answer is not 100% right because they don't have that 2 with it. So just as a reminder to myself, I do a little arrow so that I won't forget that I need to include that in the answer. So this kind of brings my attention over here so that I don't forget. Okay, now that I've factored out the GCF, I can go ahead and create my X box and determine how I'm going to change this trinomial into a 4-term problem. Now, a lot of students ask me, what if I forget? Like, what if I didn't notice that the 2 was there and I kept solving the problem? Well, technically, you can do that, okay? It's going to be a lot harder because instead of using your AC method and getting 1 times 12 and 12 being in the top of the box, you're going to have 2 times 24. So your number up here is going to be 48. So it's a whole lot easier to figure out the factors of something low like 12 than something higher like 48. So this saves you time and it makes the problem easier, okay? But you could go ahead and solve it, but here's the thing. At the end, you would have, in your final answer, you would have a 2 that you would have to factor out at that point. So it's in your best interest just to knock it out at the beginning. If you forget, hopefully you would catch it by the end. But yeah, okay. So let's see, I've got my trinomial. I want to go ahead and do my X box. All right. I've got my A. I'll use my blue again. My A is 1, my B is 7, and my C is 12. So A times C would be positive 12, and B would be positive 7. So remember, I need to find 2 numbers. Multiply to give me 12, add together to give me 7. Okay, let's think about the signs real quick. If I'm multiplying and getting a positive, okay, well that narrows my choices down. I know that my numbers are either going to be both positive or both negative. That's the only way I could multiply and get a positive. So which one is it? Well, let's look at the bottom to help us. So if I'm multiplying and getting a positive, and I'm adding and I'm also getting a positive, that means that my 2 choices have to be both positive. And it might be a trick to just remember that if both your top and your bottom are positive, both of these are going to be positive too. That could be a little shortcut to think about it. But if this 7 was negative, then both of these would be negative. So I would be multiplying 2 negatives to get a positive, adding 2 negatives to get a negative, okay? But when these are both positive, these are both going to be positive, okay? You kind of got to get the hang of that with the signs, but again, with practice makes perfect. So let's think of everything that goes into 12. Well, I showed you the calculator trick. You can use that if you need to, but 12 is a pretty low number. I can think of all of them right off the top of my head. So I've got 1 and 12, 2 and 6, and 3 and 4. So looking at all my options, my 3 set options, both being positive, which ones would add together to give me 7? So 1 and 12, no, there's no way. That's going to give me 13 every time, not 7. What about 2 and 6? Well, 2 plus 6 is going to be 8. So no, that one's close, but it's out. What about 3 plus 4? That would be positive 7. So 3 times 4 would be 12. 3 plus 4 would be 7. Now, a lot of students, just like over here, we asked, does order matter? And we said yes. And the only reason why it mattered was because our signs were different. Here, does order matter? Technically, no. All right, I could have put the 4 here and the 3 here. If they're both the same sign, that doesn't matter. It's only when they're opposites that it would matter. Okay, so I'm going to turn this 3-term problem into a 4-term problem using my 2 new numbers. So x squared, a stays the same. B is going to split, okay, using my 2 new numbers. And I gotta remember to keep the signs with them and to add an x on, because the b value always has the coefficient of the x. All right, and then my c stays the same. So all I did was I took b and I split it in 2 using my 2 new numbers. Okay, so now I have a 4-term problem. How do I solve 4-term problems? Hopefully you're saying to your computer, factor by grouping. And the answer is yes. Okay, so we group together the first 2 and the second 2. Make sure you include that sign with the second pair. All right, what's my GCF of my first group? Well, 1 and 3, that would just pull out a 1. And then x squared and positive x, I could give out x squared and 1x, that would just give me an x that I'm pulling out. So let's go ahead and do that. Let's divide out that x. X squared divided by x would just be x. 3 divided by 1 would be positive 3. X divided by x would cancel. So that's it. Let's look over here. I always take that sign and I bring it down. Okay, 4x and 12. So I know 4 goes into 4, and I know 4 goes into 12. So 4 is going to be my GCF. I can't factor out an x because that has 1, but that doesn't. So I can only take what they both can give me. So no x here. So let's divide out that positive 4. 4x divided by 4. The 4's cancel, and all I have left is x. Positive 12 divided by 4 would be positive 3. Now, I ask myself, do I have twins? Have I created twins? Yes, I have. They're exactly the same. So I know I've done good. So now I group together what I have in front of the parenthesis sets. So x plus 4. And I bring down one twin. Now, hopefully your eye is being brought over here because that's what we need to make sure we include with our answer, that 2 that we pulled out at the very beginning. So I just need to include it in my answer by listing it out front. This would be my final answer. Again, in a short time, we're going to be learning how to actually solve these, and we'll take it a little further. But because this is just an expression, there was no equal sign given to me, this is as far as it can go. Okay? So this has been Miss Math Tutorials.